Nice job on the first spin. Hello to you too, Fembox. You know, hopefully you're not last. My God. I know everyone else has this issue, but if music is too calm, I feel like it drives me crazy. It has the opposite effect on me, like 90% of the time. If you wait first, that's true. Yeah. Okay, YouTube stream is live. This place might be nice in the future, but it's not the vibe right now. I want something that. All right, this song's a banger. I just want to listen to it. And I'm just gonna go to the radio for it. Okay. Oh, you missed out, Jed. All right, so I'm damn it, Twitch, do your job. I'm a little over it today. I do not feel at all like hunting around on the internet for questions. I do have a DM on Reddit that I'm gonna check, but I think I'm just gonna go straight into Algebra once we see if we have anything to do here. Oh yeah, this person, they integrate secant of 3x, they got their answer. Wolfram got a different looking answer, and I was finding out it really is the same answer. Person says thanks. Might be using that technique, but I've heard. Okay. So yeah, I don't think we have anything to do here. Oh yeah, Jed, I was lurking on Zach's stream and I saw you helping out with that ninja triangle problem. When he was looking at it on Thursday, I figured out in my head the whole construction with your worst case scenario. Unless there's a you know another one. I came with the same worst case scenario that you guys did with you have no red circle immediately below the previous red circle. Like it has to be at least 2 over. I didn't get as far as noticing that there's like that logarithmic relationship though. Ooh, 15 streak, nice. I mean, the song ends so abruptly because it's part of the album. Actually, you know what? We're listening to the album. I haven't listened to this album straight through once. This is the album is Evil Squad 3 by Radar, and Radar is spelled R-A-Y-D-A-R. Everything this person does is kind of a banger in terms of I'm not the biggest fan of electric music or EDM or whatever, but I think it's like synthwave specifically, but this person I like. Yo, Walrus, how goes it? So I think I saw Penn Center. I know for a fact that I saw Penn Center doing number 25 out of the book, and I left off on 24, and I still want to figure out 24, so I don't think I actually did it. I think Penn Center is done with chapter 3, so I don't mind doing any of these other ones in chapter. Wow, chapter 3 has so many questions. Oh my god! Studying for your math final. Ooh, good luck. It's going good. It's kind of a busy day, but I'm glad to have the stream running. So I've seen you doing like studying on your streams, but I'm not sure what like math class are you actually in? All right, so yeah, I guess I think probably for the algebra I'm going to be doing today, let's just take anything we want out of chapter 3, right? I'm going to start with 24, but let me make sure there's nothing new in the reading group Discord. Good, okay. And if you don't want to say what math class it is, that's completely fine too. I was just like curious, but it was easier for competition math. Oh, I didn't know that you do competition math. That's super cool. I never tried to do competition math because it seems like there's a lot of tricks involved. Geometry 1 though? Okay. Yeah, I think I'd rather do competition math than geometry, honestly. Ooh, song's going a little hard. Let me turn the music down. All right, so I'm looking at 24 here. Competitions are fun but humbling. I bet. So I haven't done a competition, but I've run into like, you know, other math students in my classes who are just on another level of being able to do math above me, and it's kind of crazy to, or it like it's not crazy that someone's above me, but it's it always just feels crazy to see like this thing that I've been struggling with, this person just does with ease. Scary, yeah. So if we're splitting n as an even positive integer and h is a subgroup of z sub n, which is integers addition mod n, seeing kids do questions you can't solve before you can read the question. There's a... like, it feels very like against the spirit of competition, but I feel like there's always going to be someone who's better than you. And you just have to kind of like learn to deal with that. I guess that's the conclusion that I've come to in life anyway. Prove that either every member of H is even or exactly half of the members of H are even. Even if you are the best, you'll still have your strengths and weaknesses. Yeah, absolutely. See all the solution to the problem. Just make sure you're better than everyone else. Yeah, Chad. There you go. And they were talking about 24, and it's like, wow, Chad, I didn't think you liked algebra. Yeah, you don't like abstract algebra, which it still boggles my mind that the word algebra is used in so many different ways in math. And it's an even positive integer, and h is a subgroup of z sub n. You could offer hints on 24. I'm still trying to kind of like work through what this means, I guess. If n is an even positive integer, you're doing addition mod n. Okay, but before I ask for a hint, let me just work through some examples. I think that's going to help me wrap my head around what this problem is actually asking. And I don't remember like what the technique was, but I do remember seeing Penn Center do 25. I don't remember anything about it though. Some of these problems building each other. A lot of them rely on previous problems. Not necessarily even the immediate problem before it, but a lot of these problems do build on each other in general. Come on. This song's pretty good too. Suppose n is an even integer. I mean, it's like I'm super early on in this abstract algebra textbook as well. I assume this isn't your thing, Jed, but we haven't gotten into anything that crazy yet. So let's just take oh, that's an ugh. Ooh, this eraser actually works. This is the eraser that the dude gave me when I bought this whiteboard off Craigslist, and I just assumed it would be crappy, but actually it's working much better than the one that I have. So let's just look at integers mod 6, why not? So we have, yeah, okay, 0, 1, 2, 3, 4, 5. I was just wondering if we had negative numbers, but we don't in mod 6, or, you know, the negative numbers are really 0, 1, 2, 3, 4, 5. So any subgroup we can name in this is either all even or exactly half even, half odd. So if I try to only take the odd numbers here, well, we don't have the identity. That's the issue, right? 0 is even. So immediately we can't take only odd numbers and have it be a group. We could take 0, 2, and 4, and we're closed in our subgroup. Can we take a subgroup that is... We can't really take a mix of even and odds without taking the entire group, can we? So is this really, like, we either take only all the evens or we take the entire original group, is how I'm now interpreting this. And there's no other subgroups that are even possible in the first place. Besides the trivial subgroup, I guess. Like, we have, in this Z sub 6, we have 3 possible subgroups in total that I can think of. It's been a minute since I checked chat. Hello, over on YouTube. Hello, you're having your exam soon. Can you help me out with a math question? Yeah, sure. Type your question out there in chat or put it in my Discord. You can wash those Expo erasers. You just rinse them under hot water for it. Ooh, I'll have to try that, Femvox. Can you define subgroup? A subgroup is so a group, I guess I'll say a group is, I need to explain what a group is, I guess. And a group is 5 things. It is a set of numbers, which could be integers, real numbers, complex numbers, matrices. It's not even a set of numbers. It can be a set of things. I'm just going to keep it as numbers, though, for this explanation, though. And then it isn't really a condition of a group. That's just kind of like what a group has. But the first condition for it to qualify as a group is that it has to be it's a set of numbers with an operation. Just one operation. So you only consider one operation at a time. So you can do integers with addition or integers with multiplication, but not both at the same time. Because if you do, it's called a ring, and that's another thing entirely that we haven't gotten to yet. So this has to be closed, meaning anything you do with this operation in the set of numbers, you have to land it back in the set of numbers. So if you have integers with, say, division, it's not closed because 1 divided by 2 isn't an integer. So you've escaped from your set of integers, basically. It has to be associative, which is just your normal like associative property. AB times C equals A times BC. It has to have an identity. So if you're talking about addition, your identity is 0 because 0 plus anything is itself. The last condition, and I know you asked what a subgroup is, but you can't really explain a subgroup if you don't know what a group is, I guess. And I'm assuming that you don't know what a group is, but I'm sorry if you already do know what a group is. The last condition is every element has an inverse. And the inverse is basically a number if you take A times inverse A, and we say times as like the general operation. It's not necessarily actual like multiplication, but this could be addition, it could be matrix multiplication, it could be matrix addition, it could be some other operation entirely. But basically, each element A has an inverse such that you get back to the identity, which we call E, because the German word for identity is E, or it starts with E. So a subgroup fills all of these conditions, but it's a subset of that initial set of numbers or other things. And that's all a subgroup is, but it has to fulfill all the conditions. Okay, hey SPQ. Hey Brown, it could be a set of sets? Ooh, probably. Numbers are antithetical to math. We're using addition mod 6. So you could do addition over all integers, and that's a group. In this case, we're talking about addition mod 6. So if you do 5 plus 5 in integers mod 6, you get 10 mod 6, which comes back around to being 4. So we've stayed inside our like set of numbers here. Yes. What you said, Jed. And LOL over on YouTube. If you do have that question, please type it out there. I assume you already left though. Also, hi Brownie Man. Would 0,3 be a valid? Ooh. I think it would be. Good spot, because I did miss that. Because 3 is self-inverse, so we're still close here. Okay, nice. Yeah, I didn't even realize that 0,3 could be a subgroup here. Having numbers here is bothering me. Or anything. So this is half even, half odd. Interesting. Okay, so the only half even, half odd subgroup, I think, is gonna be this whole identity with the middle, you know, like whatever is self-inverse, I guess. Order 2. It has exactly one element of order 2, I think. Now, what is a subgroup? It's the same exact thing, but you take a subset of what of whatever that group's set of numbers is. So our group is integers mod 6, and our subgroup is any subset of this that we can name that still qualifies for everything else for a group. So I guess let's make a claim. if n is an even positive integer, z sub n is the original group the identity oh, not every even number necessarily, right? You can probably skip even numbers for bigger. Like, you could take multiples of 4. I chose too small of a group to show that example, but I think if you had, like, z sub 12, you could take only 8 and 4 and you're fine. So every multiple of 2, I guess I'll say I is an integer. So you could take all multiples of 2, all multiples of 4, all multiples of 6? Is that what I'm saying? I think I'm saying that, yeah. Or, I'll look in a second. The identity and the single self-inverse element. That's my claim. Is H required to be a proper subgroup? I don't think so by the word in the question. Only when 4 divides n. Hey, SG1. And hello, critical. Only when 4 divides n? I'm not sure what you mean with those last two comments, Jed. You're trying to derive 4e to the t over 2 critical? Like that? Sure, I can show you the chain rule here. So the 4 is just a coefficient, it's going to stay the same. When you derive e, you get the same thing back out. Let me do prime. So we get 4, we get the same, now when you derive e, it's always the same thing. Now when you do the chain rule, we derive the inside, which in this case is the exponent, t over 2. Excuse me, oh my god. And t over 2 derives to 1/2 because it's just t to the 1, and the over 2 is still there. So now you can do 4 times 1/2 is 2, so you get 2e to the t over 2. Dimension doesn't have to contain every even number. Yes. And we have to come that if 4 divides n, then n over 2 is self-inverse. No problem, critical. If 4 divides n, then n over 2 is self-inverse. So the set 0, n over 2 will be valid h without including all even values of v. Yes. Ooh, wait, if 4 divides n. So you're saying if we had, my z sub 6 example isn't helpful there. Say, take z sub 8. So, well, I mean, what is n over 2? We have an even number of elements here. Are we rounding down? I assume you're rounding up. Like 4 would be the self-inverse element here. Oh, and Finvox, if you want to say that hint, please do. I just wanted to get my head around the initial like statement of the problem, but I feel like we've got something that we can potentially tackle. You need self-inverse to be even. Drilling H doesn't include. Consider a Cayley table for the group, then consider reading it mod 2. Ooh. Interesting. I'm curious where that's going to end up. I want to keep following the thread that we're on, but that's like, I want to follow that too. So you guys are saying n over 2. Isn't it n plus 1 over 2? Unless we're counting from 0. And I think it works for non-multiple 4. Like for n equals 6, 3 is the fourth element, which is n plus 1 over 2. Or some of the end of this album already? Oh, it's only half an hour. Okay. So my thought to like prove this is to kind of you're referring. Oh yeah, so it's not necessarily every even value. You don't have to do just multiples of 2. You can do multiples of 4. You can do multiples, I think, of 6, 8, 10. It might be powers of 2. Not multiples of 2. Because in Z sub 8, if you took only 0 and 6, you're not closed. So I'm kind of inclined to say powers of 2, maybe? There might be a special case where you can take anything you want. I was thinking of, I mean, all those generators are going to be just the original group right back at you, right? I'm not doing a good job of phrasing it, but I'm kind of only concerning myself with proper subgroups, I guess. because I'm saying this, I'm going to say it's obviously true for the original group. But if you take like in Z sub 6, if you just take or I keep choosing the wrong one. If you take 5 as your generator, you get all of Z sub 6 back. So I guess it's not particularly interesting. Or can you make that argument that do you cover every subset if you take each element as a generator? I don't think so. I think we did a proof that shows that you don't. Or maybe you can. No? Yeah, maybe you can. So yeah, it was that Putnam competition one that we were doing before, where 2 doesn't work, or 2 subgroups can't cover the entire group, but 3 can, right? And so if you take all generators, you cover every possible subgroup? I mean, that feels like a different claim, I guess. I'm trying to both prove that the subgroups I'm claiming to this thing to be true for is true, and on the other hand, prove that no, it doesn't work for any other subgroup, which is why I'm concerned with getting every possibility for a subgroup that exists. And I should say, for at least Jed's sake, what I mean with a generator. If you take something as a generator for a subgroup, say in Z sub 8 we take 3. This is called the subgroup generated by 3. And that's what you get when you take successive powers of 3. But the implication is that a power of 3 in the context of addition mod 8 is repeatedly doing 3 plus 3 plus 3 plus 3 mod 8. But we say in algebra, we say everything is multiplication, even though in this case it's addition. So you take, 3 to the 1 is just 3. 3 squared is 3 plus 3 is 6, which is still 6 mod 8. Then 6 plus 3 is 9 mod 8, which is 1. Then 3 plus 1 is 4, plus 3 again is 7, plus 3 again is 10, which is 2, plus 3 again is 5, plus 3 again is 8, which comes back to the identity, or no, which gets us 0, and now we're good. Oh my god, I'm sorry. And so not every generator gets the entire group back out, which is kind of what I was talking about with SPQ, but if you take just 2 as your generator, you would do 2 to the power of 1 is 2, 2 squared is 2 plus 2, which is 4, still in 4 mod 8 is 4, plus 2 again is 6, which is still 6 mod 8, plus 2 again is 8 mod 8, which is 0. And now if you kept adding 2 here, you just cycle back through. So that's the entire subgroup that you get generated by 2. You have a thought? Okay. I don't know if this idea of generators is going to be helpful though. Right. I'm just concerned that talking about generators, it doesn't necessarily cover every possible subgroup. You can define other subgroups because you can take multiple things as your generators, which I know how you do it, but it still feels very strange to me to actually do it. So I feel like we can't just do an exhaustive argument with looking at every generator. Suppose H contains an odd number. It's about odd and even elements of H. That's probably, okay, that's maybe a much more direct way to go about this. If you suppose H has an odd number, what can you say about H? The subgroup has to contain every power of that odd number, which is odd, even, odd, even, odd, even. Okay, that's probably the answer. Okay, you know what, SPQ, I think you just owned me. That's a much easier way of doing this. Let's go write that out. Okay, so suppose H less than or equal to Z sub 6 has an odd element 2k plus 1. Then the subgroup generated by 2k plus 1 is less than or equal to H, because in order to be a subgroup, you have to contain every power of all of your elements. In the subgroup of generated by 2k plus 1 is 2k plus 1, 2k plus 1 plus 2k plus 1, which is 4k plus 2, which is an even. 4k plus 2 plus 2k plus 1, which is 6k plus 3, which is odd. This is the point here, I think, yeah. I think it's a much simpler way that kind of avoids all of this stuff. You're going to get an alternation odd, even. We should technically show that it ends on an even number, right? How can we do that? This is probably the most important realization of the proof, though, that you can just do this. We just have to work through the little, this little detail here. Yeah, what Fenbox said there. So if you do like 2, 3 over here to continue the example, it's everything generated by 2, everything generated by 3, and everything generated by any multiple of 2 plus any multiple of 3. So you get a whole bunch of different possible combinations. For Z, you'll just end up getting Z sub 8 back out, but it potentially gets complicated for other more complicated groups. So like if you're doing it actually for like all integers, not mod, the subgroup generated by 2 and 3 is every multiple of 2, every multiple of 3, and you call like every multiple of 6, every multiple of 18, every multiple of like, you know, things that are 2 and 3. How do we show where this group ends? Eventually it includes, I mean, Every time we do one of these subgroups, they end in the identity. It's gonna end with 0. Right? And I think that's how we show it's... If you have an odd number, it has an even counterpart. So pair, 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 and then it ends in an odd even pair. Now we can suppose there has an even element to the other part. This isn't really a formal proof, but I feel like this is... I would take this as my proof here. I think I'm comfortable doing that unless someone points out something that I'm glossing over. Technically, we didn't show it for H, did we? We should have for 2k plus 1. So I guess we should extend it in some way. I don't know really how we would extend it though. I don't know. I think maybe this argument, if we make both of these arguments at the same time and H is any combination of these generators, I think we're taken care of. Maybe. Like we're gonna have, like this 2L subgroup is gonna be just these even numbers embedded in here. I didn't do that right. 4L. I guess we're going back to the whole thing where, like, are we covering every subgroup by only considering a single generator? I don't think we are, but I think you make an argument that any other subgroup is going to be some kind of combination of those generated ones. What was the last thing I said? Oh, I don't know what the last thing I said was. You don't believe my claim that 2k plus 1 is less than or equal to h? Really? Math should be counted as foreign language class? Yeah. Hello to Erdy? You had a question. How can I find the distance of these locations? You're looking up. Real question. Hey, syntax error. The distance in these locations I'm looking up? I'm gonna need some more information from you, Erdy. Thanks for the follow, by the way. Like, what locations? Are you talking about, like, if you have 2 points? Yeah, well, we have to hear back from Erdy. Let's talk, Jed. Oop. Ah, I joined the wrong channel. Okay, fine. This one works too.
I just joined you here. So I want to go back over something you just mentioned.
Okay.
You said, okay, so you were talking about the generators, when you're combining generators 2 and 3.
Yes.
That we have to include everything generated by 2, everything generated by 3, and everything generated by any multiple of 2 plus any multiple of 3.
Yes.
So my question is on that third point. Is it not sufficient to say anything generated by 2 plus 3 or whatever your operation is? I don't know how you designate that, because anything with anything generated by a multiple of 2 plus a 3 would automatically be a multiple of 3 and already in that first set of anything generated by 3. And likewise, anything generated by 2. You see where I'm going with that?
Well, if you take like,
So you used like 18 as an example because you could double 3 and get 9 and then multiply that by 2 and you get 18, right? But every multiple of 18 is by definition a multiple of 3 or a multiple of 2.
yeah, so if you take two things that are relatively prime, you end up covering, like, if we're talking about just all integers,
Yeah.
If you take things that are relatively prime, like the book gives 8 and 13, you do end up getting to every single integer. If you took like 2 and 8, then you're certainly leaving out like odd numbers and things like that.
Right.
But
I guess what I'm getting at is it necessary to consider every multiple of the first and every multiple of the second, or is it, for that third term, or can you assume every multiple of the first thing joined with, or unioned with everything in the second thing, unioned with everything that's generated by the sum of those two, or the operation, whatever, if you're doing addition on this, I guess, 2 plus 3, which would count your 5, your 10,
yes.
so on. But you don't actually have to consider like 2 2s and a 3 because it's already been picked up
Yeah,
by
you'll.
the 3. Or if you're doing 2 and 4 as your generators, you don't have to consider 2 2s and 4 because it's already picked up by 4, because 2 2s would be a multiple of a 4, which you've already included in the set done by 4.
Yeah, if you have like duplication, you don't really care. If that's your question.
I guess, no, well, yeah, that's what I'm getting at. It's like you mentioned every multiple of the first and every multiple of the second. But if you consider only the cases where it's the first and the second, and the generation produced by that, would that be sufficient? You don't actually have to consider every multiple of the first or every multiple of the second. You only need to consider
I mean,
the first,
yeah,
because otherwise you've got redundancy. And just
okay, yeah. I mean, true. You could just cut straight to doing every multiple of the first plus every multiple of the second, and include in as like the 0 times case, if that's what you're thinking.
Or just I guess the only thing you really have to consider is, given two generators, let's just call them F and G, all the values generated by F, all the values generated by G, and the value F plus G. Because anything else would already be a member of G and or F. You only need to consider that base case, right?
Well, no. If you have like 2 and 3, you still need to do some work to get to 7. Or
no, 3 includes 7.
Not directly. You have to do.
Sure it does.
1 3 and 2 4s.
1 4 7. It's the fifth element of the Z8.
Oh, if we're talking about Z8, I was thinking of all integers.
Okay, you're talking about all integers?
Yeah, if we're talking about Z8, then yeah, things get like a little too simple too quick. But
okay, so 2 and 3, you have to include 5.
Yeah, like you take one of each to get to 5.
Okay,
and then
I see what you're saying. If you're doing all integers without
like mod, yeah.
Without a mod, okay.
Because
I can understand that then.
You can do it for like mod 8 or whatever too. It just gets like you have so few numbers that you just always end up with the original set back. So I was trying to give a better example. Sorry, if you just said something there, you got cut off.
Okay, sorry. Am I back?
Yeah, you're good.
Okay. Is the set of all integers? I guess the set of all integers is closed then, doesn't it?
Yeah.
Okay.
It's closed under addition and multiplication. Oh wait, integers. If you multiplication, you have to remove 0. But yeah.
Okay.
Some weird like
all
rules.
Right. I just want to get some clarification on that. I guess assuming that we're dealing with only with this modded set.
Oh yeah, you can equally valid do it with. You can also do it with all integers, not just mod. But yeah.
Okay, I can see the argument. Thanks for that clarification. It's just easier to chat this out than try to type that up.
For sure, yeah.
Okay, thanks.
Okay, thank you. Bye. Okay. So let me back up and catch up with chat here. So we did basically a demo of the theorem you advertised yesterday. Oh yeah, Schrader Bernstein or something. If you're looking at before I get to that, though, let me look at what Erdi is saying in syntax error or saying. If I was looking in the middle of Kansas and I wanted to make it to Vegas, what would be the calculation? I think Google Maps is your best bet there. Like, it won't do it like as the bird flies. Maybe there's a way that you can make it do that. I don't know. Yeah, I think Walrus has the idea where like there's some you probably have to do some special thing because latitude and longitude have like there's some weirdness involved there, but I think that's basically the idea that you would get the coordinates and you can do your well, even then we're in a sphere, so the normal distance formula isn't quite right, but it'll be good enough for between Kansas to Las Vegas. Measure distance. Oh, really? If I make a mistake, I mean, I hid my browser for a reason, but if I make a mistake and open up Google Maps on stream, it's not gonna, it does zoom in to where I live, but I can always zoom out and then it's not gonna say anything. Can I find, no. Can I, where would this tool be? Just right click on it. Great to know you live in the New California Republic. Yeah, you don't want to share your address with the stream? You know, I don't think I do, unfortunately. Distance from here. Ah, I see. Distance. Wait, that's getting directions. Okay, wait. If I go from the middle canvas to Kansas, I can get directions. I can't get this. I can get coordinates, I guess. Oh, really, Chick? You think I should click on the one called measure distance? That sounds stupid. That's not going to measure distance. Okay. Well, I'm okay to show this on stream. So let me let me back up. I don't know if it'll show up that well on stream, but if we're in the middle of Kansas, oh, the right click does show up. The last one here is measure distance. And then you get this nice little dot. Las Vegas is somewhere down there, right? It'll do the work for you. 938 miles. Oh, that's cool. It even accounts for it being like a sphere. I assume that's what that bend is. It did that, then pasted in the search. We might start point to Europe. Oh yeah, let's see how it bends there. Oh, dude, that's kind of cool. I mean, we're not actually going through Greenland. That's kind of not the best. I mean, I don't know how you would project it, I guess. Ooh. Oh my God. Where are you going, line? Oh yeah, it's going north through the North Pole because that's the shortest distance. Oh my God. Yeah, if I want to be a Chad, how far away am I from being a Chad? Okay. Ooh. Australia? Oh. Far away from... Ooh. It's like a hook. Okay, sorry, this is a little too fun to play with here. But Ernie, when you say you did that, I assume that is latitude and longitude? You're trying to subtract north from north to find your answer? What is that, Begula? In west from west. All right, let me, finding distance with latitude and longitude. And I just want to make sure Google isn't going to like output my latitude and longitude if I Google this. It doesn't seem like it is. Okay. Trying to subtract north from north and west from west. Ernie is asking a question about finding distance with latitude and longitude. I'm also messing around with Google Maps because their distance calculations account for the curvature of the Earth, and I think that's kind of cool. So we're at like 10 degrees north and 5 degrees north. Just give us simple numbers that we can easily verify that we're subtracting them from each other. Isn't it going to be like Pythagorean theorem or something? If you want to get the simple version. Like, is this 5 squared plus 7 squared square rooted? No, that's way too big. Huh. Oh, this is nautical miles. What are latitude and longitude? Like, no, it's not. I don't know how you do this, I'm gonna be honest. It's not as simple as I thought. And earlier, sorry, syntax error. You were saying you came up with a way to compute ln of x for natural numbers. Want to check your derivation? That sounds kind of terrible. How bad is it? Yeah, you gotta do some fancy angle stuff here. Euler macaroni constant? Is there cheese involved? Let me look at this video quickly. So you subtract the latitudes, yeah. So that's your north minus north. I can show those numbers and I can't. So this isn't necessarily the distance though, or it's a distance but in very weird terms. How do you convert it? I'll look at that in a minute, syntax error. Forgot I can do this, but can you just give me a formula? Okay, what's wrong with this formula, I guess? Latitude A, longitude B, latitude A, latitude B. Can we just cut to the chase and just use this formula to make life easy? Express in radians. Ew. Hello, Oba Atrep over on YouTube. Limit as x goes to 0 of x times x? Or what is that? Or x to the x? Um, oh, but I guess I asked two different things, and I have a bad habit of doing that. When you say yes, which one are you saying yes to? X to the power of x? Or x? All right, okay, no, let me not ask a second quote question again. Okay, you're saying yes, it is x to the power of x, which I can help with that, but I have some other people who are asking questions. First, okay, so Ernie, I'm not sure I can really help with this. At least, like, not easily. This seems a bit more complex than I really know how to do. That seems like a step in the problem, but I don't know what you do with those after. Like, this video, it seems like it's only showing for things like this is different longitudes, but I think it's assuming the same latitude, and they do the reverse where they take the same longitude and do different latitudes. But you have two different longitudes, two different latitudes. And I'm not going to watch a 12-minute video on stream to try and figure it out. If I can find some kind of like a simpler formula to get this, then I'll try and work through it. But I'm not gonna be able to like learn this quickly enough on stream to figure it out. Try. I don't really know what that means, Oba. I know I can evaluate limit as x goes to 0 of x to the x. You have to use some you have to use a logarithm. So yeah, I'm sorry. There's a few questions that are like floating around it now, so I can't really spend much longer on this latitude and longitude one when I'm just not gonna be able to figure it out quickly. There might be someone around in chat who wants to engage on it more, but it's gonna take me too long to figure out. And there's the Haversine formula, big love. I don't really know how to use it though. And I think Erdy's asking about a simpler version where you can just use a trick and not a complicated formula. Yeah, I'm sorry, Erdy. Welcome in though. If you think might have math questions in general, I don't know about anyone who knows about aviation theory, but there are generally math streamers who can help out with like math-specific concepts. If you're interested in checking that type of stuff out, but aviation theory, I don't think any of us particularly know. Okay, so the syntax error wants me to check this derivation, which I've never heard of the Euler-Mascheroni constant. don't know what's happening in that thing that you posted. Syntax error. I'm trying to figure it out, and I just don't know. Yeah, I'm sorry. I don't think I know all of that one either, to be honest. You notice how ancient merchants found location using birds and stuff? Oh, wow. Funny thing is, the book you're reading from this class is from 1993? Oh, God. Are you going to be a pilot one day? Like, no offense, but if you're reading books from 1993, you know, I might want to be on your plane. Okay, let me... I at least know how to do Oba's question about limit of x goes to 0 of x to the x. So I'm gonna at least do the question that I know I know what to do. The other ones are gonna take me time. Like, I don't know. I'm sorry. I just like I don't know. I wonder if like Jeff would know about it, because I know Jeff's doing some like GIS stuff before, but I can't believe anyone else who would like possibly even know to get the distance between latitude and longitude. Okay, but anyway, let me let's do this question. So, oh, but you're asking about the limit as x goes to 0 of x to the power of x. Hey, Nikas. Yeah. Sure thing, Critical. After this question, I can help you out with yours. You have to post in your discussion stating what's new, what's been updated, hopefully filling the teacher in that we're using old material, which you're sure he knows. Yeah. Oops. Okay, so if we want to evaluate this, the whole like x to the x thing is kind of messing things up. But whenever you have like x in a power, you can use logs to kind of make things a bit simpler. There is technically a leap in logic here where once we use a certain property, we're kind of assuming the limit converges. It's always possible the limit diverges, and you would not realize that. But I feel like usually when you encounter things in a calculus class, you don't have to worry about that unless your teacher is super mean. So what I'm going to do in this next step here is... What am I going to do? Okay, because if you have the situation ln of e to any power you want, I'm just going to call it y to be different. This is equal to y. Actually, wait. I'm doing this wrong. Wait. You know, I'm gonna phrase it in a different way. Because the way I usually do it, for some reason it's not working in my brain right now. I'm just gonna say this thing converges to a limit L, and that's a possible leap in logic, assuming that it converges when we haven't proved that, but usually you get to just do that. And I'm gonna take the ln of each side now. Xcx equals ln of L. The way I think is basically equivalent to doing this, but this way it's a bit simpler for me to phrase in this moment. Hey, warm-hearted American girl. An old lady and she was mean to me. Oh. I'm sorry that you have to deal with that. That kind of sucks. Yeah, I don't know what to tell you. I've never been a hot girl, so... I don't mean to like laugh at it though. Dealing with a difficult teacher is never easy or fun. So I'm hoping you're able to, I guess, get through the class. But yeah. Okay, and now with a convergent limit, you're allowed to swap ln and limits. So let's do that. And the entire point of doing this is we have a log identity with something to raise to a power, which is this power x gets to come out front as a multiple, as like multiplication. So So x, or ln of x to the x is equal to x times ln x. Now to evaluate that, well, that's going, oh. Is the question on Discord critical? Okay. In Bagula, yeah, Ben, you do get me every time with that. Isn't that just the absolute value of cosine x times cosine x? Bagula? Sorry, I didn't know if that was like a meme or not. We'll look at it more in a second. I'm still like trying to work through this limit though. So this is that's gonna be 0. ln as x approaches 0, I think is negative infinity. So you have 0 times infinity, which is an indeterminate form, so we can do L'Hopital's. How do we want to apply L'Hopital's here though? Okay, I'm gonna say that x ln x, I need more room. I'm gonna say that x ln x is equal to ln x over 1 over x. So I haven't really changed the value of this. I'm just kind of rewriting it as fractions to force a fraction to happen, so we're able to use L'Hopital's. ln of L is still the same. Now this is a fraction and it's an indeterminate form, so we're allowed to use L'Hopital's. We derive the top, which becomes 1 over x. Right, LH for L'Hopital's there. And then the 1 over x derives to minus 1 over x squared. It's ln L. Now we can unflip the fraction, and we get something that is possible to evaluate. And we're going to check this in Wolfram alpha after. So we get negative, it'll be x squared over x. Ln L. Then as x goes to 0, it'll be just negative x. So we just get 0 here. And then we do e to the power of each side to isolate L, so we get e to the 0 is just 1, so we get 1 equals L. So I think our answer here is 1. And let's check that. You can't apply L'Hopital? Why not? Oh, thanks, Shed. Oh, did I say sine? I meant to say cosine. It does equal 1 according to Wolfram. I mean, so if you're saying that the teacher said you can't use L'Hopital? A underscore. What is that emote? I like it. How do you do it without L'Hopital's? I'm trying to figure that out. Yeah, I mean, I believe you. I just don't know how else you do it. Are you in class right now asking your teacher if you can use L'Hopital's? Are you taking a test right now? You're passing your exam. I'm not helping you cheat, dude. Fuck me. Ah, all right. The dude goes, hold up, I'll ask my teacher again if we're allowed to use Lopitals. And then a second later he says, yeah, he said yeah. It's like, wait a minute. Something seems a little fishy here. Can't hate him for trying? I guess not. Can you activate the feature so you scream he cheats? The rules against using real intelligence? Yeah. Oh, sorry, so, Begula, you're asking about, the square root cosine squared thing? Helped you cheat, thank me later. Bounding it. What? That likes to kind of change a oh, like a change of variables. I don't know exactly what's happening there. How, like, how, you kind of flip everything. And it's unlimited as x goes to infinity, but how do you magically change it back into x to the negative 1 over x? I don't see where that comes from. Warm Heart American Girl, what's the best engine Ocarina of Time? So, I've watched quite a bit of Ocarina of Time because of Pen Center and Zach and Dan. I've never actually played it for more than like probably half an hour at my cousin's house as a kid. At least from watching it though, I don't know. I guess aesthetically, what's that temple in the desert? That one has a pretty cool vibe. Can you get back before we get back to algebra? Oh, critical! Yeah, I can. Thank you for reminding me, Jed. Sorry about that. Critical. You don't know how the 8 over 5 root 3... So how we went from one side of the equation to the other. So how we went from here to here. Oh, okay, yeah. They do a little trick here, and I just said do. I'll actually write this out. So it'll be easier to see in writing, I think. I'll look at it more in a second as well. I'm kind of curious to see. Okay. So you have 8 over 5 times root 3 to the 5th. The key here is that a square root squared kind of cancels out. And we kind of hidden have we're gonna get some cancellations here. So maybe I'll write it out. There's a couple of different ways that we could write this out. I'm gonna write out root 3 to the 5th is the same as square root 3 times square root 3 times square root 3 times square root 3 times square root 3 5 times. You know, it just means to be raised to the 5th power, you just multiply it by 3, or you just multiply it 5 times. We know that root 3 times root 3 is 3. We know that root 3 times 3 is 3. And this root 3 is kind of the odd one out. So we can say this is really 8 over 5 times 3 times 3 times square root 3, which is 8 over 5, 8 over 9, 8 over 5 times 9 root 3 which is 72 over 5, root 3. And so the trick here is that you notice you look for the next even number under 5, and you can take all of those out. So there's a 4, and if you have root 3 to the power of 4, that's going to be equal to 9, using that same trick that I said there. For the record, I said it first. What did I say first? No worries, critical. I said doo-doo? Oh yeah. Oh yeah, shit. Okay. I'm still laughing at this freaking... I wonder what the thought process was of that person who's taking the test and goes to a YouTube live stream. Like, that means you have to have some earbuds somehow hidden. I tried it once in high school. I know some of my classmates would like thread their they wear like a hoodie and they'd thread their earbuds up through their sleeve and just have it like right at the end by their wrist, and then they just like rest their head like right like that. I guess that's the move, but like I had such a hard time hearing anything when I tried it once. It's like, oh, okay, this isn't worth it. All right, I don't know. There's like a lot of like logistical things there. Anyway, change to x afterwards. You only need a limit. So x approaches 0 from the right if and only if whenever x approaches positive infinity. No, I wasn't cheating. I was just bored in class and wanted to listen to music. I didn't look up some dumbass on YouTube doing math help live streams. Okay, I couldn't even figure out his problem anyway, so... No, I was probably listening to some kind of metal or something, but anyway. Dumbass Don does math, or just dumbass does math. Oh God, are you back home now, Pete? Doo-doo in France is a small plush a child keeps with themselves to get solace. Really? Relaxing the desk, nice, nice. Yeah, at some point, like, if I'm able to catch you, like, after the stream, even, I don't know how long you'll be around, but, or you don't have to be around the stream, but, like, I can send you a message or something. I'd love to see your recording settings, because I just kind of did something that seemed reasonable from what I saw people saying on Google, but, like, I should know what all the things I was changing meant. Awesome. Thank you. They had to type the question on their phone? Yeah, they did. It's like, yeah, like, you also have to have your phone, like, hidden in your lap or something, too. Oh, awesome. Thanks for... How you pronounce it? It's like de? And I was gonna make... de France. That's a phone number? That doesn't look like a phone number. Deny cookies. Oh, yeah, that is like a stuffed animal blanket hybrid. These ones? Oh, no, okay, these are just like stuffed animals. Doo-doo? It is pronounced doo-doo. Ben, this is now a French toy stream, okay? And not a sex toy either, just like regular child's toys. Oh, yeah, that'd be do. It's literally pronounced doo-doo. I want to hear the Google Translate lady say it. I know why it's so funny to me. Doo-doo. Okay, this stream is doo-doo. Types in the Google Translate from English. Okay. Oh my god. Yeah, this is my child announcement. Why? Tempting ant? And hear it pronounced? Paw. Why does French sound so weird? I'm sorry, underscore name knows his French around here, but like, it just sounds so weird to me. Granted, it is the Google Translate lady, you know. What's this? Also, I completely like I'm no longer Don does math. What didn't work about this link? I didn't get all of it, maybe? There we go. Do you want to make ugly toys with me tonight? Oh my god. All right, let's see what Ben posted, and then we'll get back to the math. Oh. Oh, you've showed me this before, I think. There's... Oh, it's like the numbers are super weird. This is math. Ducks. That's right. I'm like the French numbers get so much more messed up. Oh yeah, Danish numbers are worse, right? Yeah. Sixty, 10, 7. That's right, 3 and 4 minus a half times 20. For 20. Oh my god. All right. I maybe I won't do a whole full on like react stream here, but yeah, that's freaking. And do toi cat sing like what? Okay. Ugh. Sorry, these like little tangents are really fun sometimes. My tea is cold. A little disgusting. Let me just chug the rest of it, actually. Oh, shoot. I unmuted before I swallowed. That's what she said. I'm gonna put my mug away. 1 second. Okay. Do. All right. Sleep well, Ben. Thanks for hanging out. Everyone's a lot of frustration towards numbers. Yeah. Oh my god. Now your 3-year-old niece that doesn't exist is asking you, what's that? That's what she said means. I'm sorry about your non-existent niece. Terrible when that happens. Okay. I'm gonna be laughing to myself on dude. Or that. Well, I would need to hear it again, but like, that's just it's too funny to me. Do we? Okay. Was there anything? Were there any other threads that I wanted to like look at? Bagula, did you get your answer about the cosine squared thing? Or do you want to talk about it more? I'm scrolling up in my chat right now. You got it? Okay. Sounds overly abused, but awesome. Yeah. Okay. I guess in that case, we'll go back to doing some algebra. I think did we do 24? No, I feel like SPQ maybe raised a concern. Let me look at SPQ's message history. We're going in. What I did is basically the idea. I remember the theorem we advertised yesterday. Yeah. If there's an injection A to B and injection B to A, then A and B are bijection. Or there is a bijection. Oh, I don't know how your message got unsent. I didn't see anything on my end. So let A be a subset of all even elements of H, B a subset of all elements of H. You can construct injections as above. I think I was getting at this in mentally without all the formalism, but yeah, I was kind of thinking of how like they're contained in each other, these two subgroups for even and odd generated. Does the bijection between them, I know it means they're like the same size, right? Does that help us with the actual like point of the question? If we can show a bijection, like what does that do for us? You want TTS with French accent? No. Normally I don't like TTS on streams, but that could be kind of funny. Just saw some stupid thing that your algebra knowledge is worthless. Yeah, I mean, usually it does get simplified. If you have square root squared, usually just, you don't worry about the absolute value or the plus or minus. Technically, you're supposed to, though. If they are the same size, then the cardinality of A is exactly half, or the order of A is exactly half the order of H. Any element of H is either even or odd. What is A? Like, we don't have a set A given in the problem. I don't think I used A. So, like... And already saying, can you imagine if there was text-to-speech with accent changing as well? Different accents, different... Or same language with different accents? That'd be kind of awesome. I'm sure AI could like, do that. Probably. I know I've seen like Talos Teaches uses I think an AI to do text to speech, and that thing it like goes through 10 different accents in the same sentence, and it's kind of hilarious. Either B is empty or B equals A, and A equals... Oh, so A is just some subset of H, which was another subset. It's not quite following. Let me look at what Bagula is saying. It's... Okay, yeah, underscore hat. Yeah, I would do it the answer involving ln's or e's or whatever, but it's the same as hyperbolic arc sine. I used to be ln's. So the order of A's is actually... Is it regular sine? Okay, I was just kind of wondering about that. Bagula, yeah, it probably is just regular sine, or regular arc sine. I think it'd be 1 plus x squared for it to be hyperbolic. Okay, yeah, that makes... Okay. Yeah, if you change it to plus, then it's hyperbolic arc sine. Bagula, I hope you're still here to hear that correction. Okay, good. You are. Okay. A is all even elements of H. Yeah, I was just like, I went with underscore six, so like, I couldn't remember if it was 1 plus x squared or 1 minus x squared that would be regular or hyperbolic, so I was like, oh, I'm sure underscore's right. Well, prove every member of H is even, or half the members of H are even. If A is all even elements of H, Are you saying we can't take a further proper subgroup with an odd number? Which I guess I agree with. Ah. I must have I'm completely lost on this train of thought. So I guess I do realize that what I wrote on the board isn't really complete. Okay, maybe I should focus on what's not complete on my board and then come back to what you were saying to try and figure out like why it's helpful and what it's doing. Because I kind of like even forgot what I was arguing with all that like side stuff. So we suppose that H has an odd element, and we look at the subgroup generated by 2k plus 1. Oh wait, and yours an issue with saying that the subgroup generated by 2k plus 1 is a subgroup of H. If H has an odd element, and we're taking all the odd elements as B, I guess. Pick some odd element H of H, then do what you did. When we do the integral of sine of x squared dx? I don't know how you do that. It looks like a Taylor series one to me. Take any a in A, then a plus h is odd, or a plus h in B. But doesn't a plus h being odd mean that it would... Aren't those the same thing? Because B is all the odds? Oh, you mean that... Or as in they're saying the same thing. Okay. This operation is injective on A. It has an S function or something, Bagula? It's like a special function? Seeing coming out by the weird set theory theorem you've advertised. In our example, though, with z sub 6, we have 0, 3 as our subgroup half even and half odd. And then we have a different subgroup 0 to 4 as our evens. Those do not have the same cardinality. Well, oh, you're saying... Fresnel S integral? Fresnel? I never heard of that. Hey, Mohammed. Yeah, sure. Odds don't form a subgroup. Well, I mean, only odds. It's my favorite song. Cloud Factory by Ginger. Right, we do need 0, which is even. Show that cardinality of A equals cardinality of B very easily. Or order, I should be saying, for subgroups. That makes sense. Big Ula, that's a series. I don't know how else you would integrate that without a Taylor series. I still don't know what's happening, I'm gonna be honest. Maybe I'm just stupid today. Um... Because I feel like if we're saying that we're splitting H into two. I mean, I think we're subsets because okay, yeah, B is just a subset because okay, so A is all the evens, B is all the odds. B does not form a group, so we just call it a subset. That's fine. It doesn't eliminate any possibilities. We're not presupposing the conclusion before we've proven it. And is small h any element in the original h subgroup? I mean, so I guess, yeah, if you shift the elements of A, you're not going to change the order of A. But how do you make the claim that the order of B is greater than or equal to the order of A? Isn't that... Haven't we already implicitly assumed that things are half and half when they don't have to be until we've proven it? So, well, I'm looking at, like, I'm trying to work through each of the equalities in that message that you wrote that I just copy pasted. And I'm on the second, the order of B is greater than or equal to the order of A. Like, how do we know that already? A plus H is a subset of B. Are we taking every integer here, or like how are we assured of this? Like, if H is potentially any number of even and odd numbers from Z sub n, how do we know that the even shifted are necessarily a subset of the odd numbers? What if we don't have the same split? Like, would I take 3 even numbers and only 1 odd? Well, yeah, but they're not necessarily the same size. Like, you don't necessarily have to take every even element and every odd element in your original H. We're trying to put things about every possibility of H. Oh, we're even on number 224. That's perfect. Dr. L, thanks for the follow. I'm currently struggling with algebra, so please. Don't mind me, I guess. Do we know every subgroup of a cyclic subgroup is cyclic? I don't know if we necessarily have that as like a theorem, but it makes sense to me. So hi, Megalomorph. Uh, I'm kind of curious if there's a separate way entirely of proving this question, because this argument, like I'm just really not very comfortable with making an argument like this, I guess. Just see how far that gets us. If H is an odd element, then H is just a subgroup generated by K. Now R is less than K. This is probably more in terms that it's more possible for me to understand it, but like, this is still like, I don't know if my brain is plugged in today. Megalomorph is saying, because if we had that theorem, consider a generator G. If G is even, then all elements are even. If it is odd, then the things from KG are even exactly where K is even. Yeah, I mean, I think I've shown that idea. It's just that what is it that? It feels like I need to say something more, I guess. Oh, you did say that ages ago, Fembox, and I just never did it, because I thought I would be able to get to the conclusion of this proof much quicker. Oh yes, BQ. I mean that thing with G to the 2K plus 1 and G to the 2K are being odd and even. I think it's what I wrote in a less formal way already on the board, but I feel like that's not enough to prove 24, and I guess actually proving the rest of it is kind of what's escaping me. Maybe I want to try Fenbox's route, because I'm struggling right now. So maybe I could rephrase the idea that I'm on board, because I was saying I was taking the subgroup generated by 2k plus 1 as a subgroup of H, not necessarily H. I guess we could just make the claim that if H has an odd element, then it's generated by an odd element. I'm not trying to prove it too deeply, but I'm curious to see what Fembox is talking about, though. It sounds like an interesting, like, completely, like, different type of argument. So should I do a K table for like Z mod 6 or Z sub 6 or like... I guess I'll just do that. Uh... Oh. This is, it's like, it's just gonna get shifted by 1 each time. I guess it makes sense since we're just adding 1, but... You're saying to like mod 2 all this? It's just gonna like alternate zeros and ones, basically? Like, none of them will be like touching? You love multiplication tables? Oh, nice. I can't say I'm a fan of them, but sometimes they're necessary. I guess for me, they seem to be necessary. Oh, that's not the 3. If we can just make the claim, oh, man. If we just make the claim that if H has an odd element, then it's generated by an odd element, I think I'm just like, or I think we're just done with the proof. And maybe that isn't such a huge leap to make. And similarly, if H is generated by an or if H has an even number, well, it's not necessarily, it doesn't have to be generated by an even number, does it? Because the odd generator does get even numbers as well. if h has an odd number, is it only ever going to be this case? Or did it only look like that because I chose a low n with z sub 6? Yeah, Fembox, I see that. Oh, underscore it crashed. That sucks. Like, I feel like I get the like. I feel like like this like alternation, or like it's always 0 1 0 0 1 alternating is saying the same thing that I got to with like, if you're generated by an odd number, then you alternate odd, even, and you end with the identity 0, which is even. And so I guess I'm implicitly using that the subgroup of a cyclic subgroup is also cyclic here, but maybe we can say it's obvious enough in this case that we can go with it. Oh yeah, megalomorph. Once you start using all those terms, you lose me. I'm pretty new to algebra. Oops. No, you're completely fine, megalomorph. I know it's hard. So if you know Pen Center, I feel like I've seen you around in other Mastermind chat. So I assume you know Pen Center, but if not, you should. Pen Center is this abstract algebra reading group that I've been kind of like reading along with, and it's basically my first time studying algebra. I kind of tried to study it years ago, but I remember basically nothing. And for where we are right now, we've just introduced the idea of a subgroup, basically, in generators. And Fenlux is saying, consider a similar addition table for group H with k elements. Could be m odds and k minus n, or k minus m evens, yeah. Consider one of the rows in the table corresponding to an odd element. Now it's raised by training, says your bread and butter. Ooh, nice. Consider one of the rows on the table corresponding to an odd element. Okay. So notice is that in your 6x6 table on the board is that in every odd row, the parities of the column numbers gets reversed. I'll look at your proof in a minute underscore. So yeah, if we look at like, these are the reverse of each other. I guess when I look at a Cayley table, I don't know how you choose a subgroup like visually. I guess like what is a subgroup like? You can't just circle a column or something like that, which is what I struggle with. So I'm not sure exactly like where this. Like I'm trying to make a visual explanation if we're going to use a Cayley table, but I'm kind of struggling to come up with one, so I'm not sure where it is going instead. Like, yeah, we definitely do have that like flipping that happens there. There's an easy way to see subgroups from a Cayley table? Okay. Odd to even and even to odd. Yeah, I mean, so if you take, well, this feels like an expression of like, if we only think about even numbers, then we'll only ever have even numbers. But if we only ever think about odd numbers, we will have like odd and even numbers mixed. I'm not really sure where we're going with that though. The flipping will still happen in the K table for any group H. Well, any subgroup, I don't think I agree, because what if we take a subgroup with only even numbers, right? Or am I misinterpreting? What you're saying? So we're doing what, mod 6 in my example? And if you mod that with 2, you just get all zeros, I guess. Adding odd number flips the parity. Okay, sure. You're starting with an even number. This is the proof that underscore put in my Discord, and I think it's maybe pulling together something similar to what I saw SPQ saying. And it might be nice to see it like all in one place here, like tied together rather than like across Twitch messages. Oh, it's like. So let's, I guess, try and read through this in Megalomorph. I see you too, but let me just like focus on this image at first. The HB subgroup of Z sub n, suppose H has an odd element called H. Let A be the subset of H containing all its even elements, and B the subset of H containing all its odd elements. Okay. Essentially, H is a subgroup of Z sub n, H contains 0, which is even, so A contains 0, thus A is not empty. Let's define F maps A to B with doing X maps to X plus H, and G maps B to A with Y mapping to Y minus H. If F is well defined because the sum of an even number and odd number is odd. Because H is our odd element from the first part of the problem. Similarly for G, then my direct calculation F of G is the identity of B. Because you have plus H and minus H, I guess. And GF is the identity of A, thus F is bijective. Okay. I'm still not like, I'm not very experienced with like these kind of like injective and bijective arguments, but I think this makes sense with showing it's half even and half odd. Where I was maybe getting lost was this has no relationship to the all even part of the proof, which I think is probably much easier, but I think I wasn't sure whether this was trying to answer that part of the proof or not. Let O be the set of odd numbers in your subgroup, E be the set of even numbers in your subgroup, assuming that O is an empty. Okay, so Megalorph was saying basically the same idea. If H is all even, there's nothing to prove, but if there's an odd element in H, use the idea to show that the odd elements have to make up exactly half of the group. Proof is a more mathy way to argue that what are you trying to prove the table example? Well, what was the original question? I guess. So there's nothing to prove. Think of adding an odd element to the group as flipping all the parities. Still producing the same set of elements that we started with. Okay, that's a nice way of saying it, Fembox. I guess it's like, oh my gosh. I guess I'm going back to like figuring out like what do you actually even need to do to prove this. No, well, I mean you can if you want Megalomorph out, but I guess apparently you are. I think it's just a bad math day for me though. And hey, Orchard Hills Artificial Intelligence on YouTube. Can you prove the space is rotationally invariant using just the metric tensor or connection? No clue. I can't. I have no idea about tensor math or anything about that. Sorry. Oh, thanks, Dr. L. Started with 4 odds and 2 evens. 2 odds and 4 evens. Why would that be no good? Prove that either every member of H is even, or you have to half. Okay, yeah, but even before you added an odd thing to all of those, it couldn't be close. Permutation of the original set. Well, it's not just, our subgroup isn't just a permutation, though. That's where the Cayley table argument, that's where I understand it less. I don't see the shit between the Cayley table and the subgroup as well. I've understood, like, from the beginning, the idea that if you start, I guess if you look at the group, so the subgroup generated by an odd element, you do go odd, even, odd, even, odd, even. And if you start with an even, you just go even, 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 even. But like, I guess it's like connecting that to the end result that we want, I guess. I'm not sure. If you want, Dr. L, I'll copy paste the question from YouTube chat. And by the way, for anyone who's new, I dual stream to Twitch and YouTube, so if you hear me talking to someone who's not there in Twitch chat, I'm probably talking to someone on YouTube, and vice versa for anyone who's here on YouTube. I mean, I know that about Cayley tables. I guess I'm missing something about what that actually means. That I know in a Cayley table that it's like a Sudoku grid where everything appears exactly once in each row and column. Oh God, how do I say, like, I know that if H contains an odd element, it must contain every power of that odd element, and that those powers will go odd, even, odd, even, odd, even. It's just that that isn't enough of a proof on its own. I feel like it's not, at least. I understand intuitively that, you know, that odd, even pair, they just put them up in pairs, and yeah, of course you'll have half and half, but why can't there be other things also in that group that mess up that nice symmetry? Like, I guess, if H contains an odd number, is it generated by an odd number? Which maybe, I think maybe that Stack Exchange thread was kind of making that claim. Or it was, they proved that it's generated by an odd number. That's where I'm, that's how I would want to modify the proof that that's the proof that I think that's where my brain is going, I guess, naturally. Because I quite like that odd, even, like, idea. But actually trying to prove this bit, I don't really know. I think I'll check your answer. That's fair. No, so, like, I feel like the entire time since I started this question, I understood the idea of the proof. I just can't write out how you actually prove it, I guess. That's been my issue. Like, I feel like I know that you either have all evens or even, or you must, every odd number has an even number on either side, if you want to say it like that, and every even number is an odd number on either side. It's just like, how do you actually, like, that's not a proof, I guess, has been my issue that I've been, like, struggling with for half the stream now. We're not just making Google Translate say funny things. I'm gonna try and read through this, and then and then after that, I'm just gonna like leave this because I'm like, this feels like the stupid analysis proof I was trying to do, where I started thinking it's not gonna be that bad, and then I realized that to actually prove it, I'm in a little over my head, maybe. Mhm. I mean, I've heard the term coset. I don't know what coset actually means. So hey, Bladby. All right, fine. Let's just move on. We've beaten 24 to death. I'm not understanding that stack exchange proof either. All right, so what does 25 say? I think it's really related, unfortunately. Let n be a positive even integer and h be a subgroup of z sub n of odd order. Every number of h is an even integer. So if what would a group like this look like? Z sub 6 has even order. Let n be a positive even integer and h be a subgroup of z sub n of odd order. How is this possible? Don't you always have, if you're doing integer addition mod a positive even number, even integer, how do you possibly get a group with odd order? I have Z6 on the board right now. It has 6 numbers in it. Z6 is written at the top there. 0, 1, 2, 3, 1, 2, 3, 4, 5. That's 6 numbers, right? And that's even order. Oh wait, H is odd order. Z sub n is an odd order. Oh my god. I can't read. Okay. I thought Z sub n had odd order, and that, I think that's physically impossible. We can certainly have a subgroup of odd order. And so yeah, 0, 2, 4 is one that I was able to come up with before. I mean, and then the trivial subgroup also works here because 0 is even. as a consequence of 24, and Megalomorph also wants 24. Oh, you mean problem 24. I was thinking of Z sub 24. You're good. So yeah, I mean, we've 24 definitely applies here. If we can figure out the orders from 24, I guess. A positively even integer and let HP sub of Z sub n of odd order. So do we have to go into cases and show that the half and half? Oh, the half and half case, of course, is odd order. Wait. No. I'm sorry. Of course, it's even number because you can split it in half. Which leaves the situation. Actually, oh, does that just eliminate it? And we don't even have to prove anything about the even case? Okay. Maybe I'll actually be able to come up with a proof on my own for once. Probably not. Let's at least try though. Okay, this is actually like directly from 24, I think. Like, we don't even have to think too hard for the proof that I'm saying, and thank God, because I certainly can't think too hard today. Okay, so how are we phrasing things? By 24, H either has all even numbers or half are even and half are odd. You know, actually just in 24, did they say, oh, they said proof. Never mind. If they said show, I'll be like, oh, well, maybe we did show it without proving it, but no, they'd say proof. If half are even and half are odd, then H would have an even order. Thus, H must have all even numbers, because we've just eliminated the second case, and we know that 24 is true. So we don't have to prove the first case, we can just eliminate the second case and directly prove it. Show me. I mean, yeah, I'm just like looking for loopholes, I guess. Okay. I mean, I assume that's good enough for a proof since. I mean, for 24, I didn't do something that's good enough for a proof. But for 20, if we can accept that 24 is true, then for 25, I feel like it's enough proof, right? I'm gonna say it's enough proof. In Penn's chat, it didn't really fly there either. Yeah, Fedbox, I'm sorry. It's just like I still want to see what like step 2 is after it. To be fair, I didn't see what step 2 is. I think in any of the proofs that I've found on Google or that people have suggested in chat, but. Okay, so pen centers after 25, we go down to 28, it looks like. Let's see what's up with 28. Step 2 is question mark, step 3 is profit. Fair, yeah. Okay. So 28 says, prove that a group with 2 elements of order 2 that commute. A subgroup with 2 elements of order 2 that commute must have a subgroup of order 4. Okay, this is like a different style of proof at least. See if we can get this type of thing. A group with 2 elements of order 2 that commute. So if we name these as A and B, we know that A is order 2, B is order 2, and AB equals BA. Does that mean we have E, A, B, and AB? Is this really simple? Like, don't we just form the subgroup? And we can show that it's closed? Or do we need to do like a 1-step or 2-step subgroup? Oh yeah, we probably need to do what's the 1-step? Just show AB inverses in H? We can probably do that somehow, right? Them being order 2 might help us here. AB equals BA, order of A equals order of B equals 2. We're going to say our subgroup is E, A, B, and AB, which is the same as BA. And now let's, I guess, prove that. One step, two step stuff, you just prove subgroup has the identity, is closed, and has inverses. I think that's basically the two-step Fembox, but yeah. I didn't really look at the two-step though. I think for two-step, you prove it's closed, you prove it has an inverse, something like that. So if I were to do one step, we'd have to somehow construct AB inverse out of only these elements. And how would we do that? Can we say, oh, I see. Oh, I get it. If B is order 2, we know that B squared equals E. Multiply each side by B inverse. Doesn't matter left or right. It means B is self-inverse, and now we left to multiply by AB. We know that AB is a member of the group, and AB is equal to AB inverse, so AB inverse is a member of the group. So by the one-step subgroup test, we're good? Hey, Stooky. This one is an answer between closure and AB inverse. Okay. Back from dingalinging to today. I hope the dingalinging went well, I guess. It's going, I guess. I was just struggling super hard with number 24 from the algebra book. But I was able to do 28, I think, so that's good news. It went great. That's good to hear. Jeez, okay. We're on page 93. I just want to quickly see if I was right with the two-step subgroup test. Prove that it's closed, improve it's closed with inverses. So I think, even if I'm not calling it a two-step Fembox, it sounds like the two-step. But of course, you can do whatever makes you happy. I was just trying to like make sense of what you were saying. Okay. What else did Penn say? 30? Dirty 30? Oh, yeah, showing it's not empty. Okay. So 30 says, suppose H is a proper subgroup of Z under addition, and H contains 18, 30, and 40. Hey, Central, thank you. You're looking cute today, too. Suppose H is a proper subgroup of Z under addition. Do we take their prime factorizations and smash them all together? Well, addition, I guess. smash them all. I don't know if it's a good idea. Oh. Can you be lazy and say that H is the subgroup generated by 18, 30, 40? Well, I guess you have to make sure it's a proper subgroup, right? Which they aren't coprime. So there should be some numbers that get left out here, right? I'm getting kind of scared because I'm thinking of this like a vector space, and if you have like 3 vectors, you're nearly guaranteed to cover R2, right? Although this might be one of those cases where, you know, it's a bad metaphor, and these, you could maybe consider these scalar multiples of each other if they aren't relatively prime. Or not coprime, but relatively prime. If you determine the subgroup generated by 18, 30, 40, the thinking required becomes minimal. I am a fan of not thinking. That sounds pretty great right now, honestly, not thinking. So am I. Yeah. It's gonna be that time of day where beer sounds better and better. No, if you saw the pains that I was going through to try to understand 24, it was bad. I was not getting it. Like I got the idea, but actually proving it was another issue entirely. So okay, we could have all even integers. We could have, what else can we have? Wait, is that the only factor? They only have a single 2 in common? Is it just all even integers? I mean, if you want to go for the biggest h. Can you have a smaller h than that? What is the, okay, the GCD of 18, 30, and 40, I think is 2. And that makes me feel like we should just, this is basically positive, or not, sorry, not positive, this is even numbers. 2. Right, because you can write them as a linear, I don't know, I assume it extends to 3, if you have 3 numbers, you can write them as a linear combination. you basically have 18a plus 30b plus 40c equals 2, and you can multiply that entire equation through by any integer you want to make any other even integer. The best you can do is a multiple of 2. Okay. And that linear combination idea is the exact same as the subgroup being generated by 18, 30, 40. Okay. Cool. That makes sense, I think. Okay. We also have 31 to do. Suppose H is a proper subgroup of Z under addition, and H contains 12, 30, 54. What are all possibilities for H? Okay. So now they have at least a 2 and a 3 in common, right? 6? A 6 also. Oh, of course. If they had 2 and 3 in common but not 6, we'd have issues. 2, 3, 6, and nothing else? Multiple of integer is less than... How does that apply to 30? If m divides n. So I'm confused, like, what is... Okay, that sounds simpler to me, at least. Okay, let me think about 31. So I assume we're gonna have, if we have 3 possibilities for like their common divisors, 2, 3, and 6. Are the possibilities then integers mod 2, integers... Or not mod 2. Even, or multiple of 2, multiples of 3, multiples of 6? So 30 and 40 are there, 40 minus 30 is 10. 18 and 10 are there, 18 minus 10 is 8. Since all numbers are even, any linear combination is even too. I feel like as soon as you get, as soon as you can make 2 as an element, you know it's a properly, or you know it's a subgroup, so it must include every power of 2, right? So that's where my brain goes. As soon as you can get a linear combination that goes to 2 in your argument megalomorph, I would immediately say that it must contain the subgroup generated by 2. Which is, it's also going to end up being generated by 2 because you can't really have anything else there and have it be a group. Bigger hammer implies less thinking. To be honest, the way that I said, I think is still the simplest way to me, but I think that makes sense too. Shooting sparrows with a cannon is optimal. Yeah. Bigger hammer can't be used if you don't actually have it. Jack sparrows. The Black Pearl. Suppose that H is a proper subgroup. Oh yeah, so for 31, I'm saying Multiples of 2, multiples of 3, multiples of 6. Is there a problem with this for 31? We're on page 93. A236. Okay. Uh, 32. So we have two relatively prime numbers. And if they're relatively prime, by the same argument, doesn't H have to be Z? They did tactically remove the word proper. It's no longer a proper subgroup, which already, like, that kind of gives it. I mean, is there a different possibility besides the original Z? I don't think so. Because when you have two relatively prime numbers, their GCD is 1. Which means that any linear combination of them can be used to make any number. So I'm saying Z is our only possibility for 32. The supergroups? Oh god. Uh, 34. It's a horrible, vulgar subgroup that does not pass muster at the cotillion. Cotillion? So 34 says, if H and K are subgroups of G, show that H intersect K is a subgroup of G. Ooh. You see the same proof shows that the intersection of any number of subgroups of G, finite or infinite, is again a subgroup of G. What about super duper groups? Ultra mega groups. That's why mathematicians start competing to like make the biggest group possible. Okay, this is it's a neat one. So we can immediately show that H intersect K at the very least includes the identity. That's pretty easy. Groups formed with only your favorite elements of your favorite groups. Jokes aside, have you heard of sporadic groups? No. A free group on the Grothendieck universe? So I assume that we need to... Okay, so proving that it's not empty is pretty easy. We need to show that it's closed and that everything has an inverse? Because the one-step subgroup test, I certainly don't see a way to do it here. Spreader groups are real-life ultra mega groups. Do not fit into any infinite family? The Tits group! Jacques Tits! That's gotta be my new favorite mathematician, right? The monster group or friendly giant is the largest of the sporadic groups? Oh my god. Yeah, Big Eula. This abstract algebra stuff has been my my filler when there aren't questions from chat. French mathematicians SMH. Cardinal the monster group? Okay. Oh my god. Oh, Megalith. What is a building in math? Oh, literally a tits building. Wow. I thought you were just taking the good name of Jacques Tits and mashing it with some weird math concept. Flag manifolds, finite projective planes, and Riemannian symmetric spaces? I don't know what any of these mean. Oh, good, a spherical building. Yeah, I have no clue what any of this is. We have non-Euclidean geometries that will melt your mind Lovecraft style. Oh, I've seen the Harry Ball theorem. Let me tell you. No, there's a whole like probably half-hour to hour section of my stream where we were looking at perverted sounding math theorems. So there's Tits alternative theorem, there's the Cox-Zucker machine. I forget what else. Pierre penis? Yeah, and I hope that it's always a French mathematician too. I love how it's Pierre penis, especially because and even if the initials are PP. Ugh, I love it. And hopefully Pierre penis and Jacques Tits have some type of collaboration. That only feels appropriate. Cox and Zucker met in grad school. Yeah. So I've only worked out the easiest part of this proof so far, but let's at least start writing. are they proper? Not necessarily. So we know that E belongs to H and E belongs to K. So H intersect K. So E belongs to H intersect K. Thus, H intersect K is non-empty. All right, easy part done. The hard part, show it's closed and show it's it has inverses. Yeah. I know that everything in H must be closed and have inverses. Everything in K must be closed and have inverses. How do we know that we don't lose that in the intersection process? Well, I guess we name an element that's in both, right? Because if it only contains E, then it's the trivial subgroup. So maybe let's even write that. If H intersect K is equal to E, then it is the trivial subgroup. Subgroup? Let A belong to H and A belong to K, right? I assume this is the more interesting scenario here. And let's us make some progress here. I mean, maybe a better way to write it. Let A belong to the intersection. So A belongs to H. Oh, maybe this isn't so bad once I start writing it like this. Then, oh, should I have AB belonging to H and K? I don't think it's leap logic to, because you could always take A equals B if it's only like E into one other element. So I think we're okay to name two. Yeah, these aren't necessarily distinct elements, so it's okay to name an A and a B here. A inverse and B inverse belong to H, and A inverse comma B inverse belong to K. So A inverse and B inverse exists in H intersect K. There's probably a little too much writing. I could have only just said A for this inverse part, but we do need the AB for the closed part, right? Further, we can't say that AB is in H intersect K yet. That's what we want to prove. So we have to say AB. Oh, that's actually pretty easy. AB belongs to H, and AB belongs to K. So AB is in A. Okay, that's actually really not that bad. It's one of those things where I just have to start writing it out. That's funny sounding. Jorg Gamel worked in cosmology with Ralph Alpert. Decided to put decided to add Hans Beth in a founding paper. Beth never worked with them, just so that in alphabetical order of something like alpha, beta, gamma. Oh! That's nice. These US-based memes are deliberately manufactured while French math speaks for itself. It's true. Jacques Tits was a... not manufactured. All right, so third word isn't as bad as I thought it might be. The next step is 36. Let G be a group, let A belong to G. Ooh, I haven't done a single thing with centralizers yet. Prove the centralizer of A is equal to centralizer of A inverse. You should formalize 34. Oh, I didn't do the parentheses part. Yeah, I assume for 34, the thing that I did, it seems formal enough to me, at least. But, yeah, for an arbitrary number of intersections. I didn't even think about that, did I? See, it can always show it's not empty because you will always have the identity, and I assume that's your most important. That's like the most important thing. That if you keep taking proper subgroups, you'll eventually just become the identity. Same idea works? Okay. Syntax probably annoying? Probably. All right, so what do we know about centralizers? Let A be a fixed element of group G, the centralizer of A and G, C of A set of elements, G that commute with A. Right, wait. Yes. A is just there, and then you take everything that commutes with A. Whoa. The centralizer of A is a subgroup of G. Well, we know that the inverse commutes, right? By the definition of a group, like the inverse has to be the inverse on the left and the right. So they do always contain each other. Doesn't necessarily prove that the two centralizers are equal, though. I think we need to do some A and B stuff, right? I mean, basically the proof is that if something commutes with A, then that same thing commutes with A inverse. Is how I'm thinking about it. Let's establish that C of A, oops. I don't know if this fact should be helpful, but just to get out of my brain, the inverse is contained in centralizer of A, and A is contained in the centralizer of the inverse. let B belong to the centralizer of A, which means AB equals BA. Yeah, no, I don't know what to do actually. I thought we want to get to the centralizer of A equals centralizer A inverse. I was hoping that you could just like left multiply HI by A inverse or something and get what you want. It's not really that simple though, is it? Do you have to use one of those weird like XA X inverse properties or something like middle cancellation or something? That also that's implied by abelian. Hmm. I swear it's not. What properties of abelian groups do we have? They're kind of scattered just throughout exercises. Write down where you want to arrive. I mean, I don't know how to say it other than C of A equals CA inverse. Oh, never mind. That's not the direction of implication that I want. So I was wondering about like middle cancellation implies commutativity. Well, that's a one-directional implication. I feel like it should be both directions, but this isn't phrased in a way that we would know that. The centralizer of A to be a subset of centralizer of A inverse. Doing the whole subset argument. How could we show that C of A contains C of A inverse? You let B belong to C of A inverse and show it must be in C of A? And then you do the other way around? I feel that's kind of what I have written, though. Maybe I need to... Always... GAG inverse equals A. And there's a nice symmetry in a way. Well, I'm doing the proof like this way. I want to get that B's in C of A inverse. I'm gonna write up to the side what you said, SPQ, because I'm like, I assume what you're getting at is that something like that, but I still don't know what you do with that. It might actually be involved with what I do here. But if I just keep following what I wrote over here. We still need to get it so that, do we like left multiply each side by A inverse if I multiply by A inverse if I were to do this? B A inverse, and we're left multiplying by A inverse. And right, oh, wait, is it really that simple? You just left and right multiply by A inverse? I'm not mentally... Okay, no. Okay, maybe I'll make it wait. Reverters, I thought that if you did that left and right multiplying by A inverse that you would get something... terrible. But I guess not. Left multiply A, right multiply A. Okay, well, okay, that's just the subset of each other argument. Okay, that works. That wasn't the plan. We're going to get a result in a single operation if you invert both sides. Really? If you take GAG inverse equals A and invert both sides... Well, okay, let's see what that looks like, I guess. if you invert each side, you choose in socks that oh. I mean, I guess we weren't given that that's like the defining property of a group. Or centralizer. I mean, it basically is. If you were to right multiply each side by G. Basically, that the same elements that commute with A inverse is the argument there in that one-step proof. So their centralizer should be the same. So yeah, that's a nice, like, succinct way of doing it. I might just have like one or two more in me here. We just have 36, 37, 38, 39. For any group element A and any integer k, show that C of A is a subset of C of A to the k. So we do have to account for 0 and negative k's. Which I guess we did just show it for k equals -1. Wait, what about a to the 0? Well, the centralizer of E is the entire group. Never mind, that works. I was thinking just D, and it's like, that's not good, but... The centralizer of A is a subset of the centralizer of A to the k. So if we let B belong to C of A, well, we could just say, we can leave the statement that AB equals AB repeatedly let's multiply by A, and then use commutativity to get to A to the k times B equals B times A to the k. So we're going to let B be in the centralizer of A, but we're going to not start with commutativity. We're just going to start with a statement that's hopefully self-evidently true, which is that AB equals AB. And actually, if it's, we're just going to make something like this. Let's skip straight to A to the K. B equals A to the KB. And we can say that A to the KB equals A to the K minus 1 times A times B, which equals A to the K minus 1 times B times A, which equals A to the K minus 2 times A times B times A, which equals A to the K minus 2 times B times A squared, and so on, until we reach the statement a to the k equals ba to the k. So b is in c of a to the k. And I guess this step here is where we use the commutativity part. So there is a part 2 to this question, which is in a group, if x commutes with a, then x commutes with a to the k. The converse is not necessarily true because the proof doesn't work in both directions. Right? Yeah, if you start with b commuting to a to the k, you can't do that same manipulation. I don't think so. Yeah, I think that's good. Okay, I think I'm also gonna call this day there too, because I'm kind of tired. I'm gonna cut the YouTube stream off here, so if you're here on YouTube, I appreciate you. I'll be back on Tuesday. That's the word, with math. So goodbye, YouTube.